Hypothalamus Artificial Intelligence, HI. Digital transformation powered by real-time autonomous and intelligent algorithms. Presents its offering of services and products for mathematical modeling for Industry 4.0. Disruptive modeling methodologies to make high-complex mathematical models. The artificial brains corresponds to the scientific foundations, more specifically mathematical fundamentals, that allow to connect multiple mathematical models, algorithms or robots, exchanging information between them to obtain a common goal, and act as holistic intelligence of the organizations, or parts therein. Like the human brain, the artificial brain is composed of the following artificial components: neocortex, hypothalamus, and hippocampus. The artificial brain is the evolution of DSS under the Industry 4.0 revolution, that is conceptualized as a set of mathematical models, that exchange autonomously information between them, working online, using distributed optimization. When all the models that make up a company are solved using the concepts of real-time distributed optimization, an artificial hypothalamus is obtained. This is how the human brain faces reality, using multiple models of reality, acting permanently in parallel, to make decisions. The algorithm that simulates the hypothalamus is assembled by Optex, the HI's cognitive robot, using the models that traditionally make up a decision support system. So, the artificial hypothalamus, a part of the artificial brain, is the algorithm that control the workflow of the models of the decision support system. It includes a general math language between algorithms that guarantees that the system is in the optimal path. This is based on the duality theory. In real-time and uncertain systems, the concept of an optimal point must be replaced by that of optimal path, as the one who is always close to the ideal optimal points. Artificial brains are backed by the technological capacity of computing. It is traditional to associate mathematical modeling with large-scale computing, which today is linked to cloud computing, integrated by supercomputers of bits, and by the birth of quantum computers, and its marketing process. The current state involves the integration of edge computing and cloud computing to implement highly complex mathematical models. Highly complex mathematical models to benefit the end users. HI uses Optex to implement all its end-user mathematical modeling applications. HI-OP Chain, optimizing the value chain, is a collection of specialized solutions, based in mathematical models, for optimize the value chain. The general approach of HI is to connect predictive and prescriptive analytics models, which implies an integrated holistic vision, multidimensional space-time, of the entire supply chain. The solutions offered can be grouped into industrial enterprise-wide optimization. Industrial value chains can be conceived as multiple links that work as the union of two chains, supply and demand. The supply chain is associated with production activities, while the demand is associated with the business. These chains cannot be thought of as mutually exclusive, as the border that could divide is fuzzy. What is clear is that they are complementary and that their union affect all the value chain. HI models mainly support two types of industrial planning activities. SandOp, sales and operations planning activities that are carried out periodically, usually every month or every week, to coordinate the selling products with production activities. IBP, integrated business planning, activities that are carried out periodically, usually every 6 months or every year, and aim to perform integrated value chain of the organization planning. The solutions offered by HI to the general industrial sector are based on the integration of following groups of solutions. HI DCO, demand chain optimization. HI SCO, industrial supply chain optimization. HI bio-industrial supply chain optimization, and HI HRA, human resources analytics. S&OP may be constructed based on 8 groups of solutions or systems: production, energy, maintenance, distribution, sourcing, human resources, financial, and sales and marketing. HI view the systems as groups of equations that must be included in the S&OP mathematical problem depends on many factors, so that there is no revealed truth regarding what the S&OP problem is. Since the equations are defined in a database, The configuration of a problem is limited to selecting from the equation store which are the ones that the modeler wants to consider in the model. Optimization of agro-livestock supply chains. HiBio consistently meets all solutions developed by HI in different areas of application of mathematical optimization models, aimed at the planning and the scheduling of operations to synchronize the primary link, in the farms, with the industrial link, in the factories, of an agro-industrial supply chain, to produce food from the vegetable and the animal raw materials that are developed on the farms. The value chain covers from breeding farms, the transformation of the benefited animals into commercial products to the distribution of such products to different customers in multiple markets. Geospatially, it is made up of networks of farms, slaughterhouses, industrial plants, distribution centers and points of sale. Mathematical models seek optimize the management of the network of supply chains of vegetable raw materials, for example, corn, soybeans, fodder, and animal raw materials, for example, poultry, pigs, cattle, fish. Optimize the planning and scheduling of the industrial operations in the factories, for example, feed production, meat processing, and minimizing costs to achieve considerable savings in the process and increase the profitability of the business. Demand chain tactical optimization, models to optimize the goals to be achieved in marketing and sales activities, in the medium term. The tactical planning models are market share, aimed at analyzing the participation in a market. It aims to identify the model that explain the behavior of the market share of a manufacturer, or a brand, as a function of the market variables. Marketing mix, it helped the decision makers to determine the decisions that will maximize profits derived from the management of marketing events and sales, considering the constraints of the market, for example, budgets, business rules. Inventories policies, defining parameters for inventory management policies, focus on minimum inventories of finished products and quantities to order along all chain facilities that must meet the end customer orders. And demand chain operational optimization, to optimize short-term decisions in marketing and sales activities. The operational models are revenue management, mathematical programming models to management typical problems of pricing, optimal pricing, associated with I. Price lists, 2. Prices over the life of the product, and 3. Prices to be used in an event auction. Salesman portfolio, assign the portfolio that each vendor, physical or virtual, offers each customer, store or virtual marketplace, in the short term, daily may be real time. A seller may be a person, or a robot or a virtual marketplace. Client management optimization, artificial intelligence and machine learning models, to optimize customer relationships. Marketing campaigns optimization, optimization of sales campaigns, mainly promotions, and similar activities. The algorithm that simulates the hypothalamus is assembled by Optex, the HI's cognitive robot, using the models that traditionally make up a decision support system. High power, autonomous optimization software for electric sector enterprises is an optimization decision support system oriented to agents acting in electricity systems, electricity wholesale markets, and smart grids. According to the structure of modern electricity markets, the support of the business decision-making power generation should be seen from two different points of view: traditional electricity systems and markets, and smart grid systems. For the traditional wholesale electricity market, some of the models are electricity wholesale systems and markets, economic perfect dispatch, economic regulated dispatch, Carnot-Nash equilibrium dispatch, electricity and gas dispatch, unit commitment, electricity dispatch, and financial analysis, maintenance of regional national grid, electricity supply chain design, and risk management, and energy trading and risk management. For the smart grids business, some of the models are forecast of renewable energy sources, forecast of electricity demand, smart grid economic dispatch, smart grid unit commitment, smart grid network design, smart grid network reconfiguration, electricity trading, and risk management, maintenance smart grid assets, and dynamic workforce scheduler. Oil supply chain optimization. The oil industry includes global processes of exploration, extraction, refining, Transportation and marketing of petroleum products. The largest volume products in the industry are fuels, natural gas, fuel oil, and gasoline. However, petroleum is the raw material for many chemicals, including pharmaceuticals, solvents, fertilizers, pesticides and plastics. Oil supply chain optimization meets all the software solutions developed by HI, in different areas of application of mathematical optimization models, oriented to planning and to scheduling operations, in different business of the petroleum product supply chain. The table presents a summary of the oil production and the transformation mathematical models developed by HI. The table presents a summary of the oil transport mathematical models developed by HI. Oil enterprise-wide optimization integrates mathematical models for each of the links in the oil supply chain, in such a way to management the planning of the supply chain with a holistic vision. The design of HI Oil AWO was the result of work done for a multi-business oil company. The union of models, and their coordination, forms the hypothalamus of an oil enterprise. Optimization applied to mining and metallurgy. Mathematical programming in logistics operations in ports supports the following decisions: strategic level terminal allocation, and capacity planning. Medium-term tactical planning, berth allocation, macro yard planning, and maintenance of equipment. Short-term planning, stowage planning, key crane assignment, auto-loading, and discharge, yard micro-planning, manpower scheduling, vehicle routing, and maintenance scheduling. Operational scheduling, manpower scheduling and dispatch, vehicle dispatching, and stowage replanning. Cities and regions. Analytics, smart and sustainable. HI RPO, Regional Planning Optimization, is a set of mathematical models to support planning regions formed by urban and rural areas with a high degree of integration. The models' mathematical programming are oriented to land use urban planning. It determines the spatial relationship between the inhabitants, companies, social systems, equipment, and transportation systems, so scientifically that project what the future development of the urban's regions. Land use urban and rural planning. It integrates the RPO-URB with FOSSUM, Forest and Agricultural Sector Optimization Model, modeling in a nonlinear programming dynamic model for integrated planning of urban and rural regions. Regional Economic Computable Equilibrium. It models urban and/or rural regional economies based on concepts of computable general equilibrium through the simulation of techno-economic input-output systems. Location/use of social infrastructure. It determines the optimal network and use policy in the development of master plans of social infrastructure such as schools, hospitals, police stations, libraries, solid waste, public space, food supply, etc. Regional food supply planning. It simulates the supply of food to cities based on the optimization, design and operation of the logistics chain that is required for this purpose. Public project management support. Public project management support, based on a computable general equilibrium model, CGE, to simulate the evolution of the economy of the city and its area of influence as a result of implemented investment projects. Water resources planning and scheduling. A comprehensive system of water resource planning oriented to the optimal regional planning in all aspects related to the intensive use of water resource. The model addresses the multiple uses provided and/or for the control and resource management. Public health management. Mathematical methodologies for epidemic management based on high complexity mathematical methodologies will prevent the most deaths. Like Herbert Simon, hypothalamus artificial intelligence believes that the computer-based mathematical modeling is the greatest invention of all times. Thank you for your attention.